Well, this is a new thing. So this has been developed by the NASA research organization here for their own use.
As a way to improve our ice shape documentation capability in the Icing research tunnel.
This lets us really capture the 3D features of an ice shape and also have it in a format that can be very useful.
Well, traditionally, the industry uses pencil tracings of the ice shape, where we cut the ice using a heated plate so that we can generate a 2D cut of one location on the ice.
And that may be fine for some ice shapes, but if you have an ice shape that are very complex and have lots of three-dimensional characteristics, then the 2D cross-section cuts that we used to do just isn't adequate.
It doesn't capture the shape of the ice across the whole span of the model.
The ice scanning process begins once the ice is accreted on the model.
The very first step is to go in and paint the ice to make the surface of the ice fully reflective so that the laser scanner can pick up the surface of the ice.
After that step, the arm-based measurement system is brought into the tunnel and mounted to the tunnel floor and in front of the test article.
You manually move the scan head across the ice shape in order to capture all the detail of the ice.
The scanning process can take anywhere between 10 minutes up to 45 minutes, depending on the resolution that the customer is looking for, and also the size or the area of the scan that the customer is interested in.
That gets all captured, and then it needs to be post-processed to close in the ice shape.
And so depending on the size and complexity of the scan, that process can take anywhere between 15 minutes up to 6 or 7 hours.
They get a full capturing of the ice shape. So they get a 3D model of their ice shape. They can use those models in CFD codes. They can use those models to generate artificial ice shapes.
This is an example of a rapid prototyped or 3D printed ice shape that was developed from one of our 3D scans. And you can see that it captures most of the detail that you would see in the icing tunnel of an actual ice shape. Typically in the past, this kind of thing could only be done using a mold and casting technique.
One more thing that this scanner lets us do is that it lets us capture the roughness that forms on the ice shapes.
Also, run back ridges and rivulets that are often difficult to capture with tracings can be acquired with this method.
So they get a much better capturing of the ice shape.
What's perhaps unique here at the Icing Research Tunnel is taking this capability and turning it into more of a production process that we can offer to customers.
And we, on the facility side, are trying to incorporate that technology for our outside customers that are working in a more production-based testing environment.